Okay, everybody, let's look at our last type of basic trig equation, which is trig equations of the form sine x equal a value c. We'll start with an example. You're going to see that it's quite similar to the tangent and the cosine examples. However, there are some additional things that we need to be careful of here. Let's do it. So, solve for x. This is example 20.7. Solve for x. Sine of x equal radical 2 over 2. Radical 2 over 2, this is one that should look familiar. I know that this is the value that you get for sine and cosine when they're equal to each other, and that happens at a 45-degree angle, or at pi over 4. That's one of those things that you could tell by looking at our table. If you had that table handy, take a look at it, or just know it, or do it from picturing the unit circle, etc. So, let's see, one solution is x equal pi over 4. Now, let's go ahead and look at the graph. Here is, let me see. All right, here's pi. There at the top is pi over 2 is right there, and pi over 4 is somewhere right around here. So this is the value where the sine function is equal to radical 2 over 2. Okay. We can turn on that radical 2 over 2. It's about equal to 0.7, as you can see on the left there. And you can see that lines up here between 0 and 1 is 0.7. It's right about there. That's what we're looking for. Okay. And move my pointer out of the way, and then we can see that point of intersection because Desmos is good at that. You'll see it's pi over 4, and then the y-coordinate, what sine is equal to, is 0.707, etc. Okay, so that's the one that we were looking for. Now, number 1, we can use the symmetry of the sine function to get a bunch more solutions. So this solution, if you travel one complete cycle of the sine function, the sine function is periodic, and the period is 2 pi, just like cosine. So if we travel here a distance of 2 pi into the future, we go up and then down and then up. Again, and to right there, that is the one full cycle later. It's from this point to this point is a distance of 2 pi. So we also get a solution here, and the solution here is 9 pi over 4. That 9 pi over 4 is obtainable if we just take our pi over 4 and we add on 2 pi. Remember, adding 2 pi, we have to get a common denominator, so this is a pi over 4 plus, and we get 8 pi over 4 if we multiply the top and bottom by 4. And then we add these together, and on the top, pi and 8 pi gives us 9 pi over 4. And, of course, we can get another value of this by adding not just a single 2 pi here, but by adding 2 pi and then adding 2 pi again. So we can accomplish that a couple of different ways. I'm going to write it this way this time, which is if we just start with that original angle, pi over 4, and add on 2 pi twice, that is, add on 4 pi. What this should do is it should give us the solution that comes exactly 2 full cycles after this through the sine function. Now, when we add these together, we get a common denominator, and that looks like pi over 4 plus, let's see, 16 pi over 4. And pi over 4 and 16 pi over 4 is a total of 17 pi over 4. Let's go ahead and just verify this guy. So we started here, that's pi over 4. We went up to here, that was 9 pi over 4. And so the next one, if we go a full cycle later, it should be this one. And the claim is that that's 16 pi over 4. You can already see that it's 4 pi, and then we're going to go a pi over 4 again a little bit farther, pi over 4 distance. And that's going to be pi over 4 plus that 4 pi, plus a multiple of 2 pi. That should give us another solution here, and let's just make sure that we have the numbers correct. That's 17 pi over 4, and the y value is still correct. It's 0.7. Now what you'll notice is that all of these solutions that we found here, and the original one, they all were on what I call the uphill side of sine, where sine is getting bigger as you move from left to right. But there's another value here on the downhill side of sine. And we got to be a little careful about finding this value. Unfortunately, we're not able to use something like odd or even as we did for the cosine function, but we can use the nice symmetry that's captured in the following idea. If you know the sine of an angle, pi over 4, well, you will get the same sign if you go pi, start here, and subtract that same angle. So here it's up to pi over 4. This is pi minus pi over 4. And that'll give us another angle that works. Let's write that down, and then we'll come back and we'll see what the value of it is here. So recall, sine of x, is equal to, sine of pi minus x. And so if we know an angle pi over 4 has the correct sign, then we can just find the angle pi minus that angle, pi minus pi over 4, should also have the same sign. So let's go ahead and do it. In our case, the x that we started with was our original solution, pi over 4. So we should do here pi minus pi over 4. This should give us another angle that works. Pi minus pi over 4, well, getting a common denominator, that's going to be 4 pi over 4 minus pi over 4. And combining together 4 pi minus pi on the top gets us a total of 3 pi over 4. And my claim is that if x is 3 pi over 4, then it should have the same sign as pi over 4. And that means that it should have the sign equal to what we want, which is radical 2 over 2. Let's go ahead and just double check that 3 pi over 4 is a solution. The thing to remember from this is that we used pi minus in order to get the other value. We started with an original value. This one we just got from the table or from knowing the values of sine and cosine at common angles. And then the second one we did pi minus that. And that may seem like a familiar process from a previous day. Okay, let's go back over and look at the graph again. Here we are. We had pi over 4, that was this value. If we highlight it. And then here's pi minus pi over 4 is this one, which is 3 pi over 4. And you'll see that that gets the solution that's on what I call the downhill slope of the sine function, where that sine function is decreasing as we move from left to right. Now, since the sine function is symmetrical, if we go up one period, which is 2 pi, from here that's down whoop to right there, we'll get another value. This one is going to be, well, the original 3 pi over 4, and then add on 2 pi to get that value right there. And that'll give us another new value for this thing. So let's go ahead and calculate what it is. So we have a x value 3 pi over 4. And what we'd like to do now is find another, so x is equal to that 3 pi over 4 plus 2 pi. What does it give us? Well, it's 3 pi over 4 plus, and then we get a common denominator, so this is going to be 8 pi over 4, and adding them up, we get 11 pi over 4, etc. Okay. We're looking a little bit like we have a situation like we had before, which was the situation of two different formulas that we have to figure out a way to put together. So the original formula, I'll make a note of it up here, it looks something like this. X is equal to pi over 4 plus 2 pi n, where n is 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. But that only gives us half the solutions. Those gave us the solutions that were on what I call the uphill slope of the sine function. And then the solutions that we got down here, the 3 pi over 4 and the 11 pi over 4, we could get another one by adding another 2 pi onto that. We would get yet another one. And they're all going to look like this. We take the first one, 3 pi over 4, and then we add 2 pi to that as many times as we want. 2 pi n, where n is equal to 0 or plus or minus 1 or plus or minus 2, dot, dot, dot. Okay, so we have these two formulas and we somehow want to combine them together. the combining them together, I think, is quite clever, the way that it's done. I will give you the formula, and we'll plug it in to check that it works. But it's one of those ones that you just have to get used to, or you have to plug in a bunch of times to make sure that you really believe it. Remember, what we really want is a way of capturing these two lists of answers. The list that starts with pi over 4, because this is of all the things you get when you add pi over 4, and the list that starts with 3 pi over 4 and gets all the things that you get when you add 2 pi to those 3 pi over 4s. So those two lists we want to combine into one. And here's how we do it. I claim the answer is this, and we will just check it to make sure. Claim that the answer is x equal minus 1 to the power n. That one's a little bit strange because there's not a minus 1 in there anywhere. But okay, times our original pi over 4. Plus n times just pi. Not 2 pi, which is a little strange. And this is n is equal to 0, plus or minus 1, plus or minus 2, dot, dot, dot. So I claim that this formula captures all of the solutions that we got above. Here's how we're going to check. Let's just try plugging in n's, various n. Okay? So, n is allowed to be 0, so when n equals 0, we have that x is equal to minus 1 to the 0 times pi over 4 plus 0 times pi. Now, what's nice about this is that the 0 times pi, that cancels and is just 0. You might be a little concerned about this power, but a power of 0 just turns the whole thing into a 1. So this is like having a 1 in the front. So this is equal to 1 times pi over 4, which is just equal to pi over 4. So when n is 0, this formula gives us the solution pi over 4. Okay, how about when n is equal to, I'm going to do 2. I'm going to just do even numbers for now, although we want to try both even and odd numbers. Let's just do 2 for now. If n is equal to 2, then x is equal to minus 1 squared times pi over 4 plus 2 times pi. Now, the minus 1 squared, that thing is just going to equal 1, because minus 1 times minus 1 is 1. So this is 1 times pi over 4 plus 2 pi. And that's pi over 4 plus 2 pi. If we add those together, we need a common denominator, so that's going to be pi over 4 plus 8 pi over 4, which is altogether 9 pi over 4. When n was 2, this formula gave us 9 pi over 4. Let's do it one more time where n is equal to 4. If you're asking yourself, what about the odd numbers? You should be. We're going to come back and do those in just a second. So n equals 4. X is equal to minus 1 to the power 4 times pi over 4 plus 4 times pi. Minus 1 to the 4 is minus 1 times minus 1 times minus 1 times minus 1, which all comes out to just a positive 1 times pi over 4. So that's pi over 4 plus 4 pi. And when we add those two together, we get pi over 4 plus 16 pi over 4. And that altogether gives us 17 pi over 4. I hope that that's a familiar looking number. I'm pretty sure it was one of the ones that we came from before. So plugging in just the even numbers 0, 2, and 4, we've gotten the answers pi over 4, 9 pi over 4, and 17 pi over 4. And if you look up above, those were exactly the ones that we got in our first series. Pi over 4, 9 pi over 4, 17 pi over 4. So in our formula, these are the ones that come up from putting in the even numbers. Now, what I'm hoping is that when we do the odd numbers, we're going to get the ones that are listed down here. Let's give it a try. So let's try plugging in now n equal 1. So then x is equal to, well, our formula, just to remind you, our formula is here. Let's make that a little smaller so we can read it. X is equal to minus 1 to the power 1 times pi over 4 plus 1 times pi. Now that minus 1 to the power 1 is just a negative 1. That's negative 1 times pi over 4, negative pi over 4, plus pi. This is negative pi over 4 plus pi, or pi minus pi over 4. Minus pi over 4 plus, this is 4 pi over 4 if we get a common denominator, and altogether if we add those up we get positive 3 pi over 4. That 3 pi over 4, you'll notice, that was the original first one that we got when we were looking at the other set of answers. I'm hoping the next one will be this next one, 11 pi over 4. That will be some kind of reassurance that this formula really does capture all of the answers of both types. Let's do it. N is equal to, the next odd number is 3. So x is equal to minus 1 to the power 3 times pi over 4 plus 3 times pi. Minus 1 to the 3 is minus 1 times minus 1 times minus 1. And 2 of the minuses cancel and become 1. 1 of the minuses is left, so that's altogether is a negative. It's negative pi over 4 plus 3 pi. Negative pi over 4 plus 3 pi, well, we need a common denominator. It's minus pi over 4 plus, that's 12 pi over 4. And adding those up, we get 11 pi over 4. If we wanted to get yet another solution, these are all just different angles we can plug in for x that solve our original problem. If we wanted to get another one here, we could just plug in another number. It can be any number, n equal, and it can be any number we haven't used so far. So far we used, for n, we used 0, 2, 4, 1, and 3, which is, I think, the number 0, 1, 2, 3, 4 is what we've done so far. So we could plug in n equal 5, or we could plug in n is allowed to be negative, negative 1, negative 2, and so on. Whatever we choose for n, as long as n is an integer, a whole number, or a negative whole number, or 0, then whatever we plug in for here, we're going to get another solution to this equation here. And somehow the way that we capture all of those solutions together is by this claim. And what I'll do is I'm going to erase this fact that it says claim and just call that instead our solution. So that's our solution to this problem. The original example was solve for x, sine x equal radical 2 over 2. And our solution is x is equal to negative 1 to the n times pi over 4 plus n times pi, where n is either 0 plus or minus 1 plus or minus 2, or so on. That means n is an integer. All right, that's it. We'll start next time looking at slight complications of these and see what we can make of them.